Hello everyone. So we are back with another tech talk. And today we have with us Ayon. He is an executive data scientist at Nielsen IQ. He's the person who conducted the first and the largest Kaggle Days community meetup in India. So today he'll be talking about his ideas on can artificial intelligence replace software engineering. So welcome Ayon.
Thanks, Satakshi, for the invite. Thanks to the entire team for setting this event up and for bringing me on the stage. At least I feel privileged to be sharing my viewpoints on this topic because why I thought this topic can make sense to the public. It's like because it's more majorly towards the college audience and they are more towards the artificial intelligence is the thing or software engineering is the thing or where should I go because both sides have its own pros and cons and somewhere the college student gets too much information overload that okay artificial intelligence is the new hype I should go there, and sometimes it happens that actually their interest lies into software engineering or the logics and other things they may perform better in software engineering domain. So I thought that maybe because catering to the audience of the college it would be better if we could dive into what these two domains are and what the differences majorly are, so that you could take a sound call and you would not be in a dilemma that okay if I would have done that it would be have been better decision for me, or if I would have done this would have been a better career growth for me. So maybe this session brings a little bit of information to you, clarity on your thoughts, and maybe you can go home and do a little more research basis the content that I provide. This is not a 100% accurate information I would say, but it is just an effort to help you take a sound decision on the basis of the certain pointers that I will be discussing. So, as Satakshi mentioned, I am currently an executive data scientist at Nielsen IQ. So, like, I hold that so-called sexiest job of the century title. I would say, like, how when this Harvard survey came in, like, data science is the sexiest job of the industry and kind of things. So then the boom started, like AI, data science, machine learning. This used to exist from 1950s, like 1950s onwards. The research around machine learning has been going around, but then one such report comes into picture and then we all as students start flocking into one direction that okay Harvard has told that this is, or Harvard or any other survey has told that this is the sexiest job of this century, this would pay greatly, or this would be the only job in the industry going like going 10 years down the line kind of things. But I would say it's not that, like I have been into that position. Just a clarification that it's not that it's the only sexiest job of the industry. You should be in the domain where you enjoy, and you might ask that Ayon, was it like you became data scientist just because of that terminology or that domain? I would completely say that I used to love, like I used to, or I still love mathematics and kind of things, and I somewhere thought that data science or playing with maths, playing with stats would be somewhat I would enjoy daily working with. So that's the only thing that I had in mind before going into data scientist job role, not that report that states data science is the sexiest job of the industry. I hope that makes you clear that do not go with just only report titles that this is the job, this is that job, or follow what your passion is. And mentored 95 plus hackathons. I would not say judged because I usually mentor whenever if I'm judging, it's also mentoring only so that the teams could do better and better in the next avenues. Delivered 60 plus technical talks. Plus, I would say this one talk of organized by GDS JIT brings that number one more time. Thanks, Satakshi, for the invite and helping me increase that number. And I brought the Kaggle Meetup community in India that's majorly around data science, machine learning, Kaggle, and as such. So, like that's a short. I would not say short, but definitely a little bit long intro of me. Uh, Starting with the session, like I would walk you through the agenda of what we would be discussing so that we know that what's the content flow or how the things would work in this session. I would try to keep it more information specific so that you are not again bombarded with information. It's just that single liner definitions, so that you could get an idea that okay what this domain is and if this domain is for me or not. And again I'm speaking, don't go just by the words. This is just the feed, like this is just the thinking process for you to understand that okay something like this also happens, something like this also exists, and you could explore. So we will start with what is artificial intelligence, just for folks who want to know, and what is software engineering. Where do you see this? Like AI, software engineering, when we talk about these things, where do you actually see these domains in practice? Because usually what happens in college, we ask the professors that, okay, you are making us teach these topics, but where do I use them? Or like, let's say you are giving me this 8085 microprocessor or things like that, but the main thing that comes in your mind, how would I actually use it in the industry? And then you get a more inclination towards that okay, this is how the things would be working, and it's very interesting to study. So we would discuss where do we actually see these, what are the differences between these two, like what's the difference between AI and software engineering, and that also sets the base for can AI replace software engineering. So that's I would say that's a question which has not been answered yet, but I hope I can share my viewpoint so that you could also strengthen your thinking process around this topic. What's the current scenario, both in terms of AI, both in terms like another in terms of software engineering? What's the future scope? Scope hai kind of thing. But what's the future scope specifically domain wise, and what to do now? Because when once you leave this session, maybe 35 minutes, 40 minutes, we try to discuss this and what to do now. You could gain something out of this session, go home, even if you are in home, might be watching this from home, but still like you could close this session and and can take certain additional steps on top of the things that we discussed. So what is artificial intelligence? What is software engineering? What is artificial intelligence? Though they don't require specific definitions, but keeping in mind the college audience, maybe some folks are just starting, some folks have been into this industry for a long time. So just to set the base for all. So artificial intelligence, it's like when I was talking that it has been in existence from 1950s, like where you used to mimic the intelligence of a human brain. I would say like we have human intelligence. If we say we as a humans have intelligence, and when we try to bring that type of intelligence into a machine, we are trying to bring that type of intelligence artificially. So that's the thing, like how we as a human think, we are trying to replicate those type of thinking processes into a machine. And that's because it's an artificial way of doing things. That's why artificial intelligence. And it's you make the machines learn, you make the machines trained. That why I'm telling training or learning, because when we were a child, we used to be told that do not go near the candle, we do not go near that hot object because you might get hurt, right? But what we did, we as a child were too much curious to know that why are they telling like this. Let's go and check. We used to put our finger on the candle and then would get we would get hurt, and then would come back, and from the next time we would never touch that candle again, right? That's how we learn. We learn from the experiences that okay, this thing is not for me, this thing is not good, or this thing would hurt me. We try to use those kind of learnings, and then we would take the future decisions on the basis of that. Similarly, artificial intelligence is like we try to make the machines learn that okay, see, this is how the things are, this is the correct way, or this is somewhat the correct way of doing things. And now we have fed you the data, fed you the processes. Now when something like this comes in the future, or something close to this comes in the future, take the decision accordingly. And that's why we're trying to bring an intelligence to that, so that humans are not spending 24/7 of their time near a machine to monitor those processes. It's an art of training machines to perform certain tasks. And now you would tell that okay, where is machine learning? Now you are telling that machine learning, AI, the like, if these two terms were same, why then we have these two different terms, right? Like someone would tell, or someone would usually in this industry, you would hear that AI, machine learning is all same. But I would say like machine learning is a subset of AI. When I'm talking about subset of AI has a lot more than being a machine learning thing, right? Like you have Boston Dynamic robots and like certain robotic processes going on. That's not machine learning, maybe like that's not completely machine learning, but there are certain other aspects into AI too, which we would not go. AI is a very big domain, but when we talk about machine learning, AI, machine learning is just a subset of that AI. And it's like but like you try to make the machines learn, you try to train the machines. And this is a link where if in case you are interested to explore machine learning, or you would love to get certain guidance or certain pointers to follow while you are trying to make a career in machine learning, you might go to my GitHub. That's my username is Ayon, and then you would get a repository 100 days of ML code. I hope that's a brief intro of artificial intelligence. Coming to the second aspect of our presentation, that's the software engineering. So, like, software engineering, again, of definition, just to give you an idea that okay, how things work and what's the definition of this. So it's a engineering discipline, I would say. When I'm talking about engineering discipline, it's not only about engineering, it also aligns a lot of other aspects too. When a software is being made, when a certain application is being made, it's not only engineering, it's like psychology and other things also come into picture. Whenever you make a product, whenever you make a software, a lot of thought processes has gone into it in order to make it. But majorly because it's driven by a engineering or driven by a technology aspect, we try to make it an engineering discipline concerned with all aspects of software production. Like you are starting from design, implementation, deployment, maintenance, and a lot of things. And it's a like machine learning is an art of dealing with training of data of a machine. Similarly, software engineering is an art of dealing with systematic application. Like let's say you have thought of a process that I need to make certain apps, I need to make certain websites, but how do you make it? Like what's the systematic approach? How would you make that software run, scale it, or how do you make it more secure, and kind of things. Like a lot of engineering things come into picture, like security, deployment, scalability, and all other things. So software engineering packs all those things together and brings you to the complete arena of making a scalable, secure software. Like that's also innovative process, because you need to figure out the pain points, you need to see how the user would want to use your platform, you need to uh, then tune your software accordingly. So it's a complete process of technology, innovation, psychology. Like there are a lot of psychologists who work on how this software should be built, right? Like software engineering, variety of tasks, similar for the AI also. But as we go ahead, we will discuss more. And where do you see this, like coming to that college professors thing? We always have this curiosity that okay, we are learning this, we are learning that, but where do we see this, or where do we actually use them? So starting with AI applications, maybe you have seen, like if you're watching this on YouTube, YouTube has a AI application running in the background. So like you would be recommended certain videos on the basis of certain videos that you have watched in the past. Like being a dog lover, if I have searched or if I've watched videos on dogs, just random dogs, like not specific, that I'm not specific to breeds, it's like just dogs, you would see the next day or the next within the next few hours or within the next few days, you would see like a lot more videos recommended for you that starts coming in, and those would be dogs, cats, other pets. So that's application, just a simple application. And then you also have chatbots working around. Then you have like image recognition, kind of facial recognition, or like certain other applications, like working with images, working with videos, working with text, predicting what would be the sales. Like let's say I am a businessman and I run a company where we sell products during Diwali, and I want to predict how much would be the demand if I want to manufacture certain things. With the help of AI, I could predict that what would be the demand of my products during Diwali on the basis of the previous data, like previous 3 years data, how my sales have been on Diwali. I could predict certain things. So that's a rough application of artificial intelligence. Similarly, we have software engineering, Facebook, Instagram, YouTube, Twitter, like things. One thing to notice, it's like I mentioned YouTube twice. Like you would see software engineering here. Like in software engineering, I also mentioned YouTube, and in artificial intelligence, I also mentioned YouTube has its ML recommendation model running in the background. So what's the thing majorly I'm trying to focus? It's like the application, like mobile app or the web app that you're using of YouTube. So that's the product of a software engineering thought process, right? Like the entire product has been thought and brought together as an application. But in order to make this software, in order to make this application scale, or in order to make this application more user friendly, what we have done, we have tried to recommend things, we have tried to bring certain applications of AI. So inside the applications of software engineering, you first make a software, you first make a certain application, and inside that application, in order to make the things easier for the public, in order to make the things easier, better for the public, you try to include the applications of AI. So that's the thing. Like in every application that you see on the screen, they have the AI applications in the backend. Then you would not see them at the forefront. You would see a app, you would see a web version of these applications, but you would not see a bare bone application just containing AI, right? Just containing AI is not possible. It's like AI is just a support system. I hope this gives you a better idea that where the applications of software engineering and AI are. And what are the differences? Like if we talk about what are the major differences, like you might have got like a very simple idea that like simple explanation that I gave you now. YouTube as is a software, right? Like YouTube is an application that has been built, but inside that, in order to make it more like in order to make it more scalable, in order to make it more user friendly, in order to make the content specific to the users, AI applications have come into picture. Similarly, these are the differences, right? Like supporting system of a software, AI supports a lot of softwares, right? Like maybe by recommending system, like by recommending certain content, by doing chatbot type of things, right? So what are the differences? Like if we talk about the folks who work in software engineering, the folks who work in artificial intelligence, data science, machine learning, like what is the difference between these two? Like if we ask what's the difference between the day of a software of a person who works in software engineering and a person who works in AI or certain like certain related domains. So when we talk about software engineers, like they generally focus more on technology. Like let's say when I'm talking about technology, it's more into how to make that technology scalable, how to make that technology like optimized, right? How to make that technology secure, and they try to make certain web applications, mobile applications, uh, like for working with technology or working with the things that are completely user facing, right? Like you make an app, you make a web applications kind of things. These are all user facing things, or majorly in the back end, or like let's say someone would tell that okay, we build softwares that's not user facing, but somewhere or the other that software is used to track something, that software is being used to do something, right? But it's like you have a certain thing which is tracking at the back end kind of things. And the best thing is software engineers make those type of applications where they also have the provision to get the user data. Why I'm talking about this, it's like when you have mobile application, when you have web application, you also make provision to collect the user data in order to serve them better, or in order to bring AI into picture, I would say. So like certain application like a Facebook mobile app, they have made a software, mobile software, but they have also made provision to collect the user data so that they can provide you more personalized content, they could provide you more personalized advertisements. So this is the task of software engineers, to build that mobile app or web app, and to help gather the data, to make it more scalable, to make it more secure. And now the task of artificial intelligence engineers, or I would say the data science guys or the machine learning guys, they focus more on the statistics, mathematics, and technology. When I'm talking about this, it's like software engineers made a software with the provision to collect the user data. Now, once this data comes into, we try to utilize mathematics, we try to utilize statistics in order to check that okay, if this person is watching this kind of videos like dogs, cats, if that person is looking into those kind of videos, what's the probability, right? Like what's the probability that this person would also like that? When you see recommendation system, when you see chatbots into picture, it's majorly a probability, right? Like okay, like no one would say that whatever YouTube recommends, I watch all of them. No, no one would do that. If anyone does that, salute to them. So it's like artificial intelligence just utilizes statistics, mathematics to see what's the probability of a person watching this kind of new videos on the basis of certain past videos. So that's artificial intelligence, and that's where the statistics, probability, like you might have heard about this. Like if you want to go into data science, machine learning, or AI, you need to be a little bit friendly with statistics. But again, a warning: you don't need to be a master in mathematics. Like some like this might fear you that okay, if I want to go into artificial intelligence, then I need to do this, then I need to do that, I need to be a mathematics champ. No, nothing like that. Simple information. Just be focused, just be clear on your basics of maths. And software engineering teams are mostly busy implementing new features. So it's like login page or certain other features. Like let's say we have added this feature into the new version, then users can now directly send money over WhatsApp. This is a new feature, right? Earlier WhatsApp was used to for communication, and now they have introduced a new feature where you could do WhatsApp pay. So those software engineering teams work majorly on implementing the new features, and artificial intelligence teams are mostly on the back end, not making new features but running experiments. When I'm telling experiments, it's like what's the possibility, what's the probability that if a person watching dog video could also be given, certain videos could also be recommended videos which are around dog care, which are around dog foods, right? Like you have pedigree and kind of things. What's the probability that if someone is watching dog videos, what's the probability of running an experiment that would suggest videos of dog care foods or kind of things to that user? So those are experiments, those are not new features, those are just experiments that, okay, if we do this, what would be the result? If we do that, what would be the result? That's why you would uh, like, being a data scientist, I could now enjoy that privilege of being a scientist, right? Like I don't go into the labs, I don't wear those white coats and kind of things, but I also have a scientist in my designation. And why it comes into picture, like why scientist? It's like, just like scientists do an experimentation, right? Like if I do this, what's the result? Let's see. Similarly, in data science, artificial intelligence, machine learning, you try to do certain experiments, you try to check that, okay, if I do this, what will be the result? And kind of these are the differences. And AI teams majorly work towards investigating and examining the data sets. When I'm talking about investigating and examining, it's like they look into the data set, they try to get certain outputs that, okay, if this is the thing, if this is the data, how would the things behave? Or if this is the thing, how would the experiment behave? On the other side, software engineering teams work with frameworks, work with existing methodologies, combining methodologies to drive the best solution so that the solution is secure, scalable kind of things, right? So this is the major difference between the two. And the tools that are being used, it's also a little bit different. It's like AI teams majorly use Python, majorly use R kind of things. They majorly use tools for data visualization, to visualize how the data looks like. They visualize the data analytics, like they try to see, okay, if this is the thing, they try to make the analysis out of it. They try to do predictive modeling. Like when I'm talking about predictive modeling, it's like a prediction. Like just a simple example, you go on Amazon, you have, like, you are buying a OnePlus Nord 2 phone, and it would also suggest you certain phone covers, right? Like it's predicting that, if just because you are buying a phone, there is also a prediction, there is also a probability that you would buy a phone cover. That's why they give you a prediction, like probability, there, like gives a recommendation. That's on the basis of prediction, that, okay, if this person is buying phone, this person might also require a phone cover. Similarly, on the other side, software engineering teams majorly work with tools for software analysis, design, programming languages like C++, Java. They also do a software testing and kind of things. So that's a lot more fun into making optimized software product, optimized and secure software product, I would say. AI teams use the data from the software that has been built by the software engineering team in order to feed personalized content, in order to do predictions, certain kind of things. Okay, and a little bit of skill sets also vary. We have gotten an idea. AI teams are majorly working towards programming, majorly Python or R, statistics, machine learning, data visualization, deep learning. These are big terms, I know. No need to be like overburdened by these words. This is just to give you an idea that these are certain terms which exist in the world. Okay, you don't need to go today and wrap up the complete deep learning today, or wrap up the complete machine learning today. Don't go there. Just first process the things that I'm telling. What are the things which you think that, okay, these are the words, you go and search. Then software engineering, on the other cycle, they on the other part, they have programming, software development life cycles, data structure, algorithms. You need to be very fluent on those aspects. And when I'm talking about data structure and algorithms, you have, like, giving an example, linked list and kind of things. Those are not majorly used in AI teams because they have their own algorithms, right? Like you might have heard about, or even if you've not heard about, you could check regression, classification. These are all algorithms for the AI teams or machine learning teams. On the other aspect, software engineering teams have their own algorithms, right? So that's the skill set variation that I would say. And your participation in the company goals differ a bit. So like, I'm from the beginning of the session, I'm focusing on that software engineering teams focus majorly on making an optimized and secure product, right? Like which is more user friendly, which is more scalable, which is easy to use, which is easy to navigate, I would say. But on the other side, AI teams are majorly towards the business side of things. Like, why I'm talking about business side of things, it's like the type of videos that you watch. Just giving an example, the type of videos you watch on YouTube might be their dogs, might be their cats, kind of things, right? So certain advertisements come into picture, that, okay, if this person is watching dogs video, let's recommend a dog food video. Like, let's suggest a dog food advertisement. You would say that when you would see that whenever you go to the next YouTube video of your choice, you would see pedigree ka ad coming in, right? Like just to bring a certain advertisement aspect, and the companies also earn money out of it, right? Like you have money coming out of advertisements, and a lot of money has been going into the advertisement world. So AI teams and kind of things, they are majorly towards business side of things in order to drive revenue. I would not say software engineering teams are not driving revenue. Both of the teams are equally, they are driving revenues, but the way the teams are driving revenues are a little bit different. Software engineering teams make that product and kind of things, they are making that platform ready, right? At least where would I serve the ads on? AI teams told that, okay, if this person is watching dogs video, give them a face, give them a pedigree advertisement. But where would I serve those advertisements, right? I need a platform. So in order to get that platform, software engineering teams come into picture, and in order to serve which advertisement goes to which user, AI teams comes into picture. And I hope that's clear. And I'm trying to wrap up the session a little faster so that we have a little bit time for Q&A if in case there are any. So what's the current scenario? Data is increasing exponentially thanks to Geo, right? Like Geo came into India, and then the data explosion started. Like I still remember 2015 or 2014, my father used to own a phone, and we had 1 GB for entire month. You could you imagine 1 GB for entire month, and that only that 1 GB of internet used to cost around 200 or something like that. 1 month, 1 GB. And now today you go come to 2022, 1.5 GB you get easily for a day, with the monthly cost of 200 or something like that, right? So you see how much data access we have got. And just because this data access has been given to, or I would say data democratization, I would say, like almost all parts, I would not say all, but majority parts of India has got access to data and internet, I would say. When we're talking about internet, more and more devices would get connected, right? Like you have internet, you would use WhatsApp, you would use YouTube, you would use certain other platforms which are of your use, right? If a merchant is staying in Ghaziabad, or if a merchant is staying in, like, let's say Chandigarh, something like that, so they would be utilizing certain application of their choice, they would be generating the data, and they would be utilizing a product that's built by software engineering teams, right? So it's a win-win process for both. Data is increasing. And if why is data increasing? Because the software adoption has increased. More and more folks are adopting a software. Like giving an example of WhatsApp. WhatsApp as a software is being adopted by certain more and more number of users. Now it tries to bring AI or something like that. That's a different story. But it's a win-win process for both AI as well as software teams. More adoption on software, and now because there is a more adoption, more data is being generated, and the organization would now definitely want to utilize this data to personalize the experience of certain users. Like, this is a graph. This is not very recent. Today, like you would see, like today, media social intelligence today, that I somewhere see that this graph used to be true till 2015 kind of things, but then this pandemic happened, the complete digital shift happened, so this graph might have peaked a lot more than the current thing. But the main aspect is 90% of the world's data was created in the last 2 years, provided this graph is from 2000, I would say 15, 16, 17 kind of things. So if that was the scale 2 years back, now you could understand what's the scale of data that's been generated. How the data is being generated, more adoption of software by the users, right? Like more adoption leading to more data for the companies to understand the user's profile, and then utilizing AI data science on top of that. So this is also one aspect why data science, machine learning, AI is increasing now, because the user base of a software has increased. Because the user base has increased, the companies have more data, and no company would want that data is flushed into the drains, right? They would definitely want to use it so that they can earn more advertisement money or kind of things. That giving an example. And while this is true, while this might tell you that, okay, this is good for AI folks, right? Like this is very good for AI folks, this is good for data science folks, but what about software engineering? Similarly, I would say, while the data is increasing, in order to retain the users, in order to bring new users on the platform, You need products that are, I would say, optimized, that are scalable, that works on almost any device. And in order to bring all these conditions into picture, you need to focus on software engineering, right? Like if you do not have proper engineering processes in place, it's very tough. It's very tough for bringing users on the platform. If you are facing issues in bringing users on the platform, definitely no one can save you. You cannot connect the data, like you could not collect the data, you could not work on AI, you could not personalize the content. Users won't be retained. If the users are not given personalized content, users are not given personalized advertisements, it's a tough time retaining the users. So software engineering plays a major role in bringing the users, in giving that optimized environment. Once those users are in, then the actual process of AI comes into picture. And another thing, this is a very, I would say, complementary process. If you bring more users but the users are not getting anything out of your platform, like you made a platform like YouTube, and the users have to scroll down in order to get their own, like own like video or own genre of video, they would not come. But AI is supporting them, right? Like AI is supporting this user system, that okay, you watched these three kind of videos yesterday or day before yesterday, now see, this is the flood of new content that I have. So it's a balance, right? Software engineer folks made a product that too good to bring new users, and AI is now supporting to help that software scale to bring more users, to retain those users on that platform that has been built by software engineering team. And this is just a graph, because data or graph speaks better than certain words. So 73% of companies that don't conduct UX testing plans to do so in next 12 months. You see, like something would be coming up, they would test the products, they would test the certain things, and certain new features would need to be built, and then software engineering teams are at disposal, right? Like they have to work on integrating those projects or like those features. And 84% of companies plan to boost focus on customer experience metrics. How would the companies do it? They would need to bring more and more software engineering skills, right? In order to make the customer experience more better, they would need to bring new features, they would need to simplify the process of utilizing the app and kind of things. So again, software engineering book. And 97% of the sites fail at user experience. That's true, because the scale at which websites have been built in the last few years, most of them are not very good at user experience. You would say, I'm not talking about the big organizations, I'm not talking about Amazon, I'm not talking about Facebook, but majority, like those are only 3% of the entire world, I would say. If there are 100 websites running in the world, only 3%, which contains Amazon, Facebook, Uber, or other platforms, are good at user experiences, but 97% still needs to work. And that's where the potential of software engineering comes into picture. How do you make that site better? How do you make that site useful for the users? What's the future, like what's in the future store for us, given the discussion we had previously? Now, like rapid growth of data, geo boom, and democratization of data, you have more data for users, you could build the user profiles on the basis of that. But in order to retain certain users, right, like in order to retain certain users, you need to bring certain new features, you need to bring certain functionalities, you need to make certain new applications, you need to integrate certain applications, you need to bifurcate certain things. So this all goes back into making more and more scalable, optimized, secure products. A green flag for software engineering, rapid growth of data, green flag for AI. You see, where does this fit? Which interests you more? That depends on you. This is just a point of view that okay, so that you don't doubt that okay, if I'm not riding the AI wave, I'm missing a lot. No, you have lot of things in software engineering. Similarly, if you think I am missing a lot of things on software engineering, like on AI, just because I'm into software engineering, or vice versa kind of things, it's not the case. Do things that you love to work on, board any wave of your choice. It's not because just your friends are working on AI, just because your friends are working on software engineering, you go into that domain. No, right? So try to utilize the decisions, try to utilize the pointers that have been mentioned in the slides, that have been mentioned in this discussion. If you're viewing now, or if you would be viewing the recording later, make sure to put these pointers into head before you move, to take a certain decision, and so that you don't feel bad later, that if I would have done software engineering, I would have been happier, I would have been rich. No, right? So it's like, take the call where you suit, where you think you would perform better. Money, passion, like money and fame would follow. Your passion should, your passion is your thing, right? You can use your passion to go into that domain, and money and fame follows if you do certain things passionately. And this is a supply and demand by specialty. Like maybe if you want to see a graph that, okay, what's the talent supply, what's the market demand, why I'm trying to put this, it's like it can help you to see where the competition is the most, and where your scope of entering the industry is highest, right? So just wait, laser point. So it's like, this is the talent supply. Like, talent supply would say, like how many students we have or how many candidates we have for certain roles. And this is the market demand, how much is the market demand. So this is, like, just because embedded in application is here, near, like near low, it doesn't mean that the market demand for embedded in application is low. It's just a general perspective, okay? So don't think that, okay, mobile is not high, so market demand of mobile is not high. Just, this is just to give an idea, the quadrants, right? So that you get an idea that, okay, these are also domains, and you could see where my competition is. If I want to enter this, the talent supply is already high, right? And talent supply is already high, and market demand is, I would say, higher. I would not say it's lower, it's also high. You could see the optimal fit. Similarly, you would see market demand for machine learning and data science is high, because the companies have a lot of data. The companies now have a lot of data, but they don't now understand that what to do with this data. I have collected this, I have collected that, I have collected those things, but how do I use those? So that's why the market demand is higher. And why the talent supply is lower? You would say, my 10 friends are doing data science, my 10 bhaiyas are doing data science. Then why is the talent supply low? The thing is, the way we do data science, or we think, it's like the data science is actually, my 10 friends are doing data science doesn't mean the talent supply is huge, right? Out of those 10, how many of them actually know how to do software engineering? Actually, out of them, how many actually know how to do data science correctly, right? So just don't go into the numbers that 100 folks are doing this, then my competition is very tough. No. Out of 100, how many are actually doing? That's where the talent supply, when I'm talking about talent supply, it's the brightest talent that you have, because every organization wants the brightest talent. At least they claim that in their JD. You should be passionate, you should be doing this, you should be that. If everyone is wanting passionate, then the folks who are not that much passionate, where would they go? So be passionate about what you do, so that you also fit into that JD of that organization, right? So be passionate. And just because data science and machine learning market demand is high and talent supply is low, you would think that, okay, let's go this way, my competition is less. No. If you're not passionate, when you read a JD, any JD, software engineering, machine learning, you would see, be a passionate student, a passionate engineer working on this. So you need to be passionate. Supply demand by specialty is just the way to visualize things. No thing is written on stone that, okay, this is the place of data science, machine learning cannot come here, or embedded application needs to stay here for next 5 years. No, this might have changed, this might have come here, right? The dynamics of the world are changing too fast. Ukraine war, pandemic, lot of things are there going on, right? So supply and demand changes, but this is just to give you an idea that be passionate. There is a little bit of competition, sometimes more in certain domains, certain times less in certain domains. So look on that opportunity, look if you are really passionate about that. This is 2019 demand growth. AR/VR engineer, gaming engineer, computer vision engineer, and it's like 2019. These things might have changed a little bit upper and down, like as per the market dynamics. What to do now? In the end, can AI replace machine learn? Like, can AI replace software engineering? The answer is a big no. Or can software engineering replace AI? Again, our answer is no. And if someone tells yes, might be they are too biased towards that domain. Like, if I only think AI, then definitely AI can replace anything. AI can replace a human. I can tell that, right? But the reality, we know, like, no software is 100% correct, no AI is 100% correct. So we could never tell that AI can 100% replace software engineering, or AI software engineering can replace 100% AI. It's like, what's my personal choice? How do I feel when I work on that? Like for me personally, I enjoy working in data science more than software engineering. That's a personal choice. Like this is not dictated by anyone. This is not forced by anyone. This is my personal choice, right? Like I enjoy doing this. I feel that I can perform better in data science. That's why I'm into here. If I would not have felt that, I would have been into software engineering. Right? Similarly for you, see where your passion lies. And just a building hint: if you like creating things and building algorithms, building new features, or providing innovative features into certain products, definitely go for software engineering. But like you like unpredictable things. Okay, this thing I'm experimenting, but I don't know what the result would be. Scientist, right? Data scientist. So what would be the result? And you also love statistics, trends. You don't need to be an expert, you just love them. When I'm taking love them, it's not that okay, mathematics sounds a big word, I love that word. No, you love working with the concepts. Okay, and then artificial intelligence might be better for you. Again, boils down to personal choices. This is not a stone printed thing. You could you could do things as per your passion, as per your preferences. It's always a good idea. And like you might think that if I go into software engineering, I would never get an opportunity to work on AI, and if I went into AI, I would never get an opportunity to work with software engineering. There is always an open scope to shift teams in case your passion changes as the time grows, because these are interrelated. AI supports software engineering, software engineering supports AI, and we both the team members need to integrate. Both the teams need to work with each other. Like we need to talk with software engineering folks, software engineering folks need to talk with data scientists and kind of things. So it's a good idea to know a little of things, but make sure that you specifically work on a domain that you are passionate about and can help you work on that. And according to me, artificial intelligence strengthens software engineering processes. That's the single line I would say. Software engineering processes are necessary. If in case those processes are not in place, AI cannot help. And AI just strengthens the power of software engineering. If you make a software, but that's not strengthened, that's not worked upon by certain AI machine learning, the software would die down. Similarly, if you have a hi-fi AI, but not a good software which is user appealing, which is user retentive, definitely AI won't work. So that's a ball game into both the aspects, right? AI, software engineering. Focus on your interest, focus on your preference. The pointers that I gave you, like that might be useful. Artificial intelligence is growing every day, definitely the data, but new features, new innovations also are coming into picture. Software engineers jobs are not going anywhere. So don't feel that AI will eat all the jobs and software engineers won't get any job in the future. No, like there has not been any technology that can 100% replace a human. No, with more data disposal, definitely companies are focusing more on AI, but that doesn't mean the software engineering jobs would decrease or reduce. So don't worry. Follow the passion where you want to see yourself. So yes, go for it. Good luck. Like be you, if you are into AI software, like AI, definitely good career choice. If you're into software engineering, good career choice. But do not regret that. Okay, if I would have done that, I would have been at Amazon Science. I would have been at Google Research. Don't lament that. So take your call, and I completely understand your passion changes with time. Maybe you are now loving AI. 5 years down the line, maybe you are more inclined towards software engineering. Then I told that software engineering and AI work combinedly, right? Those folks talk with them, these folks talk with them. So that's how things work. If you have any questions, I'm open for them. And any feedbacks, you like the talk, anything I can help you with, you would want to personal connect, here is my email ID, LinkedIn, and website is ionra.ml. You could go and check. So yes, that's what I had for this session.
It was just an amazing talk, Ayon. We have few doubts over here. So
Mhm.
here's the first doubt.
Mhm.
The student is asking that he has a doubt. What is the difference between artificial intelligence, machine learning, and deep learning? Yeah. So
So machine learning and artificial intelligence, I focused a little bit, right? So AI is a very big domain. I would say there is a Venn diagram. Like I don't remember the Venn diagram. It's like AI is the biggest circle. So AI contains a lot of robotics and other things that are not specifically AI, like that are not specifically machine learning. Machine learning is just a way to make the machines learn and do things better. Like, let's say you are doing a certain thing, that's only if else, if else, if else. If the temperature is greater than 30, turn on the AC. If the temperature is lower than 15, turn on the heater, right? So those kind of artificial intelligence things also have been there, but this is not machine learning. This is a conditional, pure conditional statement. So AI contains all those things inside it, a little bit core things combined into machine learning, where you do not know that how the things would behave. You are not very predictable about the things. And deep learning is inside machine learning. You are trying to make the machines learn, but in order to make the machines learn, how would you make the machines learn? Sometimes you need to replicate how a human brain think. Neural networks, like we have neural networks in our brain. In order to replicate those things, in order to make a machine learn, you have those concepts of deep learning, which majorly works around neural networks, ANNs, RNNs, and all those things. I hope that clarifies. AI is the biggest circle. Inside it, machine learning. Inside machine learning, you have a little bit of aspects of deep learning, which works with human brain psychology and kind of things.
Yes, I hope the question has been answered to you, Lakshay. Now we have another doubt, that is, as you said, data is increasing exponentially, but the point will come when it will decline. What role do you think GAN is playing and will play in future for generating more and more data? Yes. So what's your
So
point?
it's
Yeah.
a, it's a, it's a good question. Data is increasing exponentially, but a point will come when it will decline. Definitely, saturation comes. Like just to give an example, during the 1990s, mechanical engineering was like CSE of today, right? So now you would see that every high rankers go into software engineer, like computer science engineering. So definitely things do reach a saturation point, and I also understand that increasingly data generation would hit a saturation point somewhere or the other. And GAN is playing, definitely GAN is a double sided sword. Why? I would say GAN can help us to do certain things, help us to generate synthetic data and kind of things, but it also aligns the path, or it opens the path for fake videos, right? So you might have seen that fake videos coming, some specific personality speaking certain lines, but that person has not actually spoken that. So that's a negative aspect of GANs. But GANs also have a positive aspect, like you could generate certain data, that generative adversarial networks, GANs, right? So what's the role I think it's playing? It's already playing a lot of role. Like, from my current experience, the projects I have worked on, we had certain cases where the data was not that much clear, the data was not that much openly available. We had to generate the data. We had, on the basis of the certain data that we have to generate certain data. So definitely GANs will play a role, but it's again on us. If we are a data scientist, if we are AI engineers, the onus is on us. How do we utilize it? How the community utilizes it? GANs definitely have a potential and can help with the data. With the point that you think that generating more data definitely it can help, but generating more fake data it can also help. We need to be very sure about that. So that depends on how we use it.
Yeah, so that's it with all the doubts the students have had today. And thank you so much, Ayon, for being here and enlightening the students with the talk. It was an amazing talk, and I really enjoyed it. Like, I am not into machine learning or artificial intelligence, but I genuinely enjoyed the talk, and it was really amazing. If you have any other doubts, please feel free to put them in the comments. We'll love to answer those doubts. So, yeah, thank you so much. We are ending up with this live stream now.
Okay, thank you team for hosting me.